So, let us begin the second part of this lecture. That is what we are going to discuss in this thing is mathematically. So, I will go back to the board now. So, therefore, you have seen that best approach of classifying this positive and negative data are basically by drawing a street and finding out the width, making the width as big as possible or maximize the width, then we can solve this problem. So, let us talk about that. Suppose I draw a vector from this point w in such a way that this vector is perpendicular to the median line. Okay, this is the median line and this is plus line, this is your minus line, right, minus line, keep in mind that. So, I draw a vector w in such a way that this is vector is perpendicular to the median line. Let us suppose that. Now, I take this negative point and draw a vector, draw a vector in a such a way that okay. So, you could see there are two vectors and this, let us say this is my unknown, one unknown. Okay. So, now the question is this is a vector perpendicular to this. Now, if I take a dot product of this vector with this with w and u, that means if I project this vector on w and after projection if the length of the vector actually goes beyond the median line, then I can say the unknown is positive. If once I project this vector u on w, if this length of this vector does not cross the median line, then I can be sure that this is a negative point. I hope you understand that. So, what is the approach we are using? We are saying that if I am unknown here and I draw a vector from this origin and this vector w is basically a vector which is drawn in such a way that is perpendicular to the median line. Now, if I project this vector u onto w and then extend it or rather then see the length, and the length is such that it crosses the median line and goes to the other side of the road, then it is a positive. If it is on this side of the road, it is a negative. So, therefore, mathematically I can write down what? I can easily write down mathematically this in terms of this. I can write down w dot product of u must be greater than or equal to some critical value c constant, okay. Or rather in generality, so this is coming from this by projecting this vector, right. This is an unknown, okay, and that I hope you understand. So, let me tell you again. So, first what did I do? I draw a vector w which is perpendicular to the median line. Then I had drawn a vector u for an unknown. Unknown means the one which you have to classify, okay, after training. So, idea should be what? If I project this vector u onto the w, then it will be long, right. If this length, the projected vector length crosses the median line, reaches on the other side, then I must be sure that is a positive point. If it does not cross the median line, remain on the left side of the median line, then I will be sure that is a negative point. That is the idea. That is why we can write down, because projection means dot products, right, cos theta, you know that is nothing but w u cos theta, that is a projection, right. So, therefore, let us not talk about that, but this is vectorically that is what we can write down. Now, in general we can write down like this: w dot u plus b must be greater than or equal to 0. Then the data point must be positive, but you can clearly see c is nothing but minus b. So, therefore, this is the first This is the decision rule, most important decision rule. Okay, we call this is a decision rule. After the boundary is made, this rule will be applied. Am I clear? So, B and W needs to be found out. That will be those values of B and W, this road will be, width of road will be maximized, that we need to find out. That is the algorithm. So, now question is, if I take let us say a positive point x plus, positive point is on the other side of this median line, this is the middle on the other side of the median line, and this plus B must be more than or equal to 1, right, because it is a positive point. So, therefore, length of this projection line must be greater than 1. Remember, this constant C or B, whatever you are thinking of, they can take any value. So, similarly, for a negative point we can write down bar stands for vector plus B will be less than or equal to minus 1. So, these two are also coming from this decision rule. I hope it is understandable and clear, right. So, therefore, what did I do? I simply taken these two vectors and then modified the equation. That is what I have done. I have not done nothing extra, nothing separately. So, now the question is, as I said, I have to make this road as wide as possible, then my chances of making error is less. So, in order to do that, how do I do it? That is what is the question is. In order to do that, we have to find out the maximization, use the maximization principle under certain constraint, okay, and what is known as a maximization or minimization under certain constraint. Then only we can find out this. So, let us do that if we can find out this mathematically in the next 7-8 minutes whatever we have in this class. Well, this cannot be done so simply, we have to use some mathematical convenience methodology to solve this problem. So, let us take an parameter y I and such that y I is positive for all positive sample and y I is negative for all negative samples. We introduce a new variable, because we have to do this maximization or minimization under a certain constraint. How do I do it? Simply this equation does not allow to find out that. So, what you can do is very simply, you can write down y I multiplied by this vector w bar x plus b, this must be equal to greater than 1, y I w bar x minus plus b must be equal to less than 1. Why it is so? Very simple. Y I is positive, then I am multiplying this factor with a positive number. Am I correct? So, therefore, if I multiply this by a positive number, this must be more than or equal to 1. But, okay, so let us take this as equation 1, and here you are using this equation 1, Okay. So, multiplying by y1 yi which is positive with this number will keep this identity same. But if I multiply this one with yi which is negative, then this identity will change, right, because this once you multiply the negative number, the identity will reverse, the less than equal to will become greater than equal to. So, you see we get both the same equations, both the equations are similar, almost exactly similar. So, now for all generality, we can write down yi w x plus b equal to 1, or rather minus 1 equal to 0, taking the minus on this left side. We can write down that this is for all this x can be anything, for all, or rather let me write in a bold, for all x s which are on gutter, that means which are on this, both this on these lines, this equality will be valid obviously, because if this sitting on the gutter, then this identity will be satisfied, correct, whether they are positive or negative does not matter. So, now you see by simply introduce this new variable yi, I can transform the whole thing to a much simpler aspects. Now, the question is how do I find out the width, how do I find out the maximization of the width. So, let us draw a different picture, but where shall I draw? Okay, let us draw here, I draw a different picture on this side and try to find out that. Okay, keeping this equation constant, try to find out that. So, I draw a simple picture, much simpler kind of things, okay, and explain to you how it can be done. So, my negative points are here, positive points are there. So, I have drawn 2 lines, right. So, one line is this and then another line is this, and then I draw a median line, right, that is what I have done. So, you can clearly see, let us put this one little bit on this side, so that you do not get confused, okay, correct. So, now as you see I draw 2 vectors, one this, okay, connecting the positive point with the origin, that is my first vector. Second vector I draw connecting this negative point with this. So, now I can draw the third vector this, okay, and therefore, the width easily can be decided if I draw a unit normal perpendicular to the median line. Okay. Can you see that? If I draw a median line, so unit vector perpendicular to median line, then this will be just the width of this street. That is how it can be done. That is how it can be easily done, right. So, how do I do that? So, therefore, this is my x minus, this is my x plus. So, this difference between these two distances x plus minus x minus, right, very simple. This vector is x plus, this vector is x minus. So, this vector must be minus of these two vectors, right, this vector plus this vector equal to this vector. So, therefore, this vector is equal to this big vector minus this small vector. Now, if I take a unit normal, remember this vector is again we have drawn here the w, this vector, the unit vector the way I have drawn is same as the vector w, right. So, therefore, this with a dot product w unit normal is what is the width of this boundary. This is the width of this boundary. Now, you see I can easily find the width of this boundary. So, what I need to find out is very simply value of this, value of this, and you can use this too to find the value of this. This is 1 minus b, this is 1 plus b. You can try that out, it is a homework. So, therefore, this width w becomes what? 2 by this. Okay? That is the width of this line. So, now I have to maximize that. So, that means what? That means I have to maximize 1 by mod w. That means I have to maximize as minimized. So, let me see, let me write down that. So, I have to maximize 1 by mod w. That means I have to minimize w square by 2. Okay. Again, why w square? Because that is basically a convenient way to express these things. Okay. So, if maximization of 1 by mod w is same as minimization of w square. So, I am leaving it there, that is what I want us to do. But if you want to minimize w, you have to use what is known as a constant equilibrium, what I discussed, or using the Lagrange constant multipliers to solve the problem. Okay. So, I am just leaving it there. In the next class, I will give you all the expressions, but how that can be done, that will be exercised as a part of your assignment problem. That is easy actually, not difficult, but you can try it out that. So, I have given all the equations actually. In this chart, I have given all the equation how to minimize that w square. Okay. So, once you do it yourself mathematics, it will be very clear. In the next class, I will give you all the final equations, the values of w, values of b to maximize the width of this. So, this is a classical algorithm which was discovered by Vabnik, and it is used as a kernel in Python and many other many other softwares which uses machine learning, and this is one of the best classification algorithm possible to find out separate between positive and negatives. Okay, anything, and material science there will be many such problems where you need to use this kind of classification approach. So, let us stop here, we will come back in the next lecture and talk about it new aspects. Thank you.